29. The most important method for the preparation of hydrocarbons of lower number of carbon, pyrolysis. Okay. Next, that's an alkene, right? Which one treatment with the B2H6 followed by product B on oxidation with alkaline hydrogen peroxide, that is hydrogen HBO method, hydroboration oxidation method, right? That follows anti-Markovnikov addition. Agreed. So OH will be in the terminal position. So you obtain the choice B, right? Okay. Choice B. Next one, but 1,9 can be distinguished most easily from but 2,1, that is using test for terminal alkene, tolerance reagent. Okay, but 1,9 is a terminal alkene, whereas but 2,1 is non-terminal. Ready? So tolerance reagent is enough. Ready? Next question. Question number 32. The compound having molecular formula C4H6. Which one treatment the hydrogen in platinum to form another compound Y, which ozonolysis gives ethanoic acid only. For a molecule to form ethanoic acid on ozonolysis, it means the alkene, you know how to think the reverse. This is an ozonolized product. Let it be oxidative ozonolysis. Okay, you know the reverse thingy. So remove the oxygen connected by a bond, so it becomes CH3. CH3. In our question, they said that a compound having molecular formula C4H6. Okay, C4H6 means CnH2 and minus 2. It may be an alkyne, right? Okay, it may be an alkane. There are a lot of other compounds having the same formula. It may be an alkane, C4H6. And which on hydrogenation? You see, hydrogen in platinum. Okay, there forms a compound Y, and the Y which on ozonolysis gives ethanoic acid. So let this be the Y, right? Okay, so this is an alkene which on ozonolysis ethanoic acid only. Okay, so from that product we can design the Y. From that Y, we can design the X. So your X should be but2,1, right? Yes or no?
Yes.
but2,1. but2,1. Okay. So the choice.
C.
Wait. The choice is C. Okay, next, the chemical system that is non-aromatic. A is aromatic, right? Because that is benzene. C is not aromatic. B is aromatic, that is naphthalene. Yes or no?
Yes.
B is aromatic, that is naphthalene. What about D? How much carbon in the first ring? 6 or 7? 6 only. So that's aromatic because they said that there is a conjugation, full conjugation, right? In the first ring there is a conjugation of positive charge. In the second ring there is a conjugation of negative charge. So they already mentioned it that there is a conjugation, so no problem. That's also aromatic. It is sure that C is not aromatic, right? Okay, C is a non-aromatic compound, agreed. Non-aromatic. It's not anti-aromatic, non-aromatic. Non-planar molecules are usually said to be non-aromatic. So you can choose the choice as C. Where C is the second one here, right? Question number 34. Which of the following statement? Consider the following statement of hydrocarbon molecular formula C5H10. C5H10 means alkene. Okay. It may be monosubstituted alkene, disubstituted alkene, trisubstituted alkene. Which of the following statements are correct? So how many C5H10s are there? Pent 1 in, pent 2 in, this one, no possible. How many pentines are there? Okay, pent 2 in, they are monosubstituted. Ready? This is 2-methyl butene. Is there any other possibility? Is there any other possibility? These all are alkenes of formula C5, H10. Hydrocarbon is C5H10, right? So cyclopentane derivative is also there. Cyclopentane, methyl cyclopentane, dimethyl cyclopentane, ethyl cyclopentane. These all are isomers, okay? One more will be here. Okay. Actually 10 isomers are there in C5H10. 5 are cyclic, 5 cyclic. So, but the question is monosubstituted alkene, disubstituted alkene, trisubstituted alkene. So we simply consider alkene, right? No. So there are only monosubstituted alkene, right? Mono or di? Is there any mono and disubstituted alkene? Substitution means branching from double bonded carbon. Okay, so this is an example for monosubstituted. This is an example for disubstituted. Example for mono. Okay, so disubstituted. So the possibility, because the valency of maximum possible substitution is 2, right? Okay, a double bond have 2 replaceable hydrogens, so the maximum possible substitution will be. So you can choose 1 and 2 as answer. Choice B. Okay, next. Methane. Huh? Yes or no? Methane can't prepare by Woods reaction. Next, which of the following have lowest dipole moment? Choice will be B, because the given alkene is a cis, right? If it is a trans, we can say that the dipole moment will be 0. Cis have a greater dipole moment, net dipole moment, because this is in the direction, this is in the direction. So have a net dipole moment, okay? So the first one is not okay. It have a considerable dipole moment. Ready? What about the second one? Second one is a linear structure, right? Okay. Symmetric alkyne, where the dipole moment is nearly 0. This is a linear structure, right? Symmetric. So if this is donating the dipole direction like this, the dipole moment will be 0. Mu means dipole moment. Okay. So usually in case of alkyne, symmetric alkyne will be, the net dipole moment will be 0. Okay. Dipole moment means that is the degree of electron donation, and will be discussed detailed in your chemical bonding. Okay.
So, T is equals to trisubstitute calculus
Also?
presence.
Choice, huh?
Second row.
Second or first?
That side. Trisubstitute will be there, sir. Right side of the alkene.
This one, huh?
Right side, sir. Right side of the double bond.
Here.
Yes.
Either. You check sample this one.
Yes.
The
Right
position?
side of the double bond.
Here.
That will be another substitution.
Here the next substitution now.
In that bond, adjacent to the double bond, there will be another substitution. Trisubstitution.
Here is the double bond to carbon. Where is the position? The total carbon will be 5. Okay. Here is substitution. Can you show?
Here it's not.
Carbon will be 6. Carbon will be 6. These are the pendenes. These are the possible alkenes of formula C5. Okay. Is there any problem? Wait. Next. What about the next question? Predict the nature of P in the following reaction. Okay, that's a typical reaction. Your non-terminal alkane can be turns to terminal alkane when when it is treated with the sodomide. Okay, so you're given with the but 2-ion, right? Okay, where it become a terminal alkane when it is treated with the sodomide. Okay, sodomide in inert solvent. So your choice will be but 2-ion will be but 1-ion. Okay, it become terminal. So the choice is C. Substitution. Okay, choice will be C. That's a reaction that you have to know. Okay, but not given in your textbook. Next, which of the following would not give 2-phenyl butane on major product in the Friedel-Crafts alkylation reaction? 2-phenyl butane. 2-phenyl butane means this is a structure, right? This is 2-phenyl butane. Agreed. So your carbocation should be sec-butyl carbocation. Okay. For a Friedel-Crafts substitution to form this molecule, your alkyl carbocation will be this one. Agreed. So using the following can produce this carbocation. Okay. What about the first? What about the first? Which is but 1 with the HF. U2 with HF become U2E, no problem. It can produce sec-butyl carbocation, so it can form that one. Next, butane 2 with the H2SO. If OH is in presence of acid, the mechanism is E1, you know. OH is removed to form carbocation. The next is butanoyl chloride, LCl3 then HCl. What about the last one? D, butyl chloride. Butyl chloride means normal butyl chloride. If this is in presence of LCl3, it become this carbocation followed by the rearrangement become secondary carbocation. So 1, 2, D is okay. So C may be the choice. What about the case in C? Case in C? Butanoyl chloride. Butanoyl chloride means that's an acid chloride of carbon 4. Okay. So if this undergoes substitution, what happens? Your electrophile will be, this is an acid chloride, acyl group. Your electrophile will be this one. If this substitutes the benzene, what happens? This will be the product. Agreed. This is Friedel-Crafter acylation. Friedel-Crafter acylation. You know Friedel-Crafter acylation where the electrophile is RCO, Cl. So RCOCl is the electrophile. So if that electrophile substitutes the benzene ring, it becomes something like that. Which on treatment with the zinc in HCl means there is Clemmensen reduction. Clemmensen, where CO replaced by 2 hydrogen, but you obtain normal butyl benzene, not sec-butyl benzene. You obtain one phenyl butane, but you have to form what? 2 phenyl butane. So this will be 1 phenyl butane. Okay. The rest of them form what? 2 phenyl butane, because the carbocation formed is a secondary. Okay. Well, here it will be a 1 phenyl butane. Okay. So not possible. What about the next? 3 is a terminal alkene, right? Ammoniacal? Very same question. Okay. You want to identify the molecule C. Molecule C is a terminal alkyne. So that we can choose that as for terminal alkene, right? Okay. What about the next? The alkene which gives same product with HBr and the absence and presence means that should be a symmetric alkene. Okay. Alkene which can give same product with HBr in presence of peroxide and absence of peroxide means there is no proper Markovnikov and anti-Markovnikov position, which means the alkene is a symmetric one. Okay, so your alkene should be butene. Butene. Is that okay? Fine. Next, you finish the reaction. First one is oxymercuration. Kusharov's reaction. You obtain ethanol, right? And your ethanol with the Grignard reagent. I think that reaction is familiar in alcohols. Ethanol with the Grignard reagent. Listen, how can you form a product when a carbonyl react with the Grignard reagent? When a carbonyl react with the Grignard reagent followed by hydrolysis, what happens? You simply make the O of carbonyl as OH. Okay, and connect the alkyl group from Grignard reagent to that particular carbon. Okay, so if any carbonyl that react to the Grignard-Reagent means the reaction leads to a formation of alcohol, and you can design the alcohol. You are given with the CO, make the O as OH, change the O as OH, and you can connect the alkyl group from Grignard-Reagent to the CO carbon. Okay, then you obtain the corresponding alcohol. So this is a reaction of carbon Grignard reagent. So here they asked that we are given with the ethane. Ethane on oxymercuration, we know that is addition of hydration, O and 2H. What do you obtain? CH3, CHO. Which on treatment with what? Grignard reagent, the formula? Okay. So that with the methyl magnesium halide. Ready? So here is the reaction. Okay. So the CH3 till now it is CH3. Make the O as OH. Okay. And you can connect the alkyl group from Grignard reagent to the particular carbon. So you are now with the isopropyl alcohol or propan 2-ol. What about the next? Oxidation. You know that a secondary alcohol on oxidation forms ketone. So CH3, C double bond of CH3. Oxidation means removal of hydrogen. Okay. And once you know the whole reaction from all chapters, then only you can do this. Okay, well the starting is from hydrocarbon. Okay, and this will be discussed in alcohols, and this will be discussed in alcohol or aldehyde. Okay, questions may be like that through entire connection. Okay, with the entire connections. So once you know once you know complete reaction, then only you can do that. That's not my mistake. Okay. Ready? Question number 42. Question number 42. It is clear that the bond is cleaved to form acid, right? Agreed. So it will be a strong oxidation. So KMnO4 in OH minus can be preferred. Is it okay? Fine. Next. Which are the following that's correct order of acidity? No doubt ethane is more acidic. Then propane. Propane is an alkane, it is more acidic than alkene. Then ethane. So choice A is better, right? Okay. A is okay. What about the first one? That's oxymercuration. Oh no. So they asked to find the intermediate. Okay, so you should know how the reaction actually proceeding. Okay, listen. For that you have to know tautomerism. CH3, C triple bond, CH. Listen, actually oxymercuration reaction means water. Okay, we simply cleave two bonds and so that supply the O and 2H. Actually this reaction is a hydration. A bond is cleaved. Since this is a Markovnikov addition, O is to here and H to here to form an intermediate. Okay, that intermediate is an enol intermediate. Enol. If you know the tautomer, it readily tautomerizes to form ketone. So what about the enol structure? C, OH, double bond, CH2. Why this said to be an enol? Because this is a double bonded OH. For single bonded OH, we are usually the suffix is anol. So this is enol. Okay. And this is unstable. Some typical enols are stable, but this is a normal enol which is unstable. Okay, and the concept will be discussed in tautomerism. So since this is unstable, it can readily tautomerize to its corresponding stable keto form. Okay, how the tautomerism means you simply shift the proton to here and bond to here. Okay, so what will be your product? This is the final product. Agreed? Yesterday we discussed this reaction something by skipping a step, right? Okay, clip the bonds O and 2H. So you obtain the product. We discussed this in this pattern, this reaction in this pattern by skipping the intermediate, but now it is asked. For that you have to know tautomerism. Okay, so that's not my topic, that's why I just okay. So now you answer. C, yeah? C. Okay. I think in your Ncert, the reaction actually explained in this pattern, but they written here as isomerization because there is no tautomerism in your Ncert. Okay, here it is isomerization. There is no word tautomerism in your 11th and 12th book, but the reaction is there, and here it is, they mentioned it as isomerism. Put it in your Ncert textbook, okay? So questions may be from here. In your Neet preparation or entrance examination, tautomerism is a good topic and it will be discussed in a detailed pattern. Should be discussed, okay? I think you are familiar with that. Next, with respect to the conformer of ethane, which of the following statement is false? Which of the following statement is true? You know what is conformers? The conformers of ethane. Soho's eclipsed staggered forms with the Soho's or Newman projection. Okay, where in the conformers, bond angles are same. Dihedral angles are changed. Dihedral angle, you know, the angle between two planes. Okay, bond angle remains same. Bond angle means if you have ethane, the three hydrogen should be in 109.5 degree. There is no difference. But the relative position of first CH3 to the second CH3, there is a plane, right? If the two CH3s are like this is a plane which passing through first CH3. If a second CH3 is like this is a plane passing through second CH3. First plane, second plane. There is an angle difference that is said to be dihedral angle. If they are exactly coinciding or exactly like this, so the planes are same. So there is no angle difference and the form is known as eclipse. If it is in a 60 degree, so it will be staggered, you know the concept, okay? That is the change in dihedral angle, okay, torsional angle, ready? But the bond angle between, this is a CH3, methyl group, always sp3 hybridized with a bond angle, bond length of same, no difference is there, okay? The bond angle of that molecule, bond length of that molecule is always same, okay? Their relative position, stereo arrangement, have only the change. The rest are same, okay? So which of the following are true means? Question number? Bond angle changes but bond length same. Bond angle, bond length change. Bond angle, bond length remains same. That's answer. Okay? Only dihedral angle changes, okay? Ready? Next, which of the following can be used as a halide component for Friedel-Crafts reaction? Azotyl chloride. You know, Friedel-Crafts reaction is either by using acyl chloride or by using alkyl chloride. There is a choice D is an alkyl chloride, isopropyl chloride. Okay? Ready? Fine. Next. Which of the following are coplanar? All atoms are coplanar. A is okay. A is biphenyl. Biphenyl is aromatic cum coplanar molecule. Okay. What about B? B is a special figure, right? B is a sp3 hybridized figure, so that is not in a plane. Not in a plane. The molecule is in a. Some bonds are in a space, right? Something are in. Actually, in cyclohexane, these valences are in plane. These dark valences are in plane, but the next are in out of this plane. That's why we are showing this in a wedge and dash. Okay, because that is an sp3 carbon. Ready? So coplanar B is not okay. C is also not okay because the terminal ends are CS3, right? Left ends are CS3. CS3 means not. It is a special figure. Like that, D is also a special figure. Okay, the choice is. Huh? A is coplanar. Biphenyl. Next, question number 48. The electron density of pyrrole is maximum at. Question GOC discussion now. So you have to know the resonance structure of pyrrole. Then only you can answer this, okay? Resonance structure of pyrrole. A bond here, a bond here. Ready? So there is a delocalization of lone pair. The lone pair is here. The first resonance structure, the lone pair jumps to here. Okay, where the valency of this carbon become 5. The valency of this carbon become, if this jumps to here, become a double bond. Double bond, double bond. Already the valency 4. In addition to that, here is an hydrogen. So valency become 5. So this carbon can't accommodate this electron, so this is shifted to here. I think you know the concept of resonance. Here is a bond, here become plus, double bond, minus charge. Okay? It continues. What about the next? This pair of electron. This pair of electron may delocalize to here, so that the valency of, if this delocalized to here become a double bond, here the valency become 5. So this to here. Okay. What about the next? This is conjugated to here. The valency of nitrogen become 5. Okay. So this electron will be here. Okay. Then conjugated here. Here will be the 5 electron. Is to here. Okay, next to here. So here the balance will become 5. So this to the nitrogen. Then it is okay, finished. This is the complete resonance of pyrrole. So it is clear that in your pyrrole, the electron density is actually this portion have electron density, right? Okay. This one also. Okay. This corner, right. This also. So all position have a chance for excess electron. Ready? What is the question? Electron densities. Question number. That will be 2 and 5, because it is clear that position same kind of electron density, right? And this is considered as 1, 2, 3, 4, 5. Okay. Among these structures, which one is most stable? Let it be 1, 2, 3, 4, 5, 6. Which one is the most stable structure? 1 and 6 are identical, right? Yes or no? So this is most stable. Resonance structure without charge is most stable. There is no charge. No charge. That is most stable. If there is a charge, then the charge will be in a nearest position. If so, there is an attraction, stability will increase. So what about the position number 2? Here is a positive charge, right? Agreed. So if the negative charge is in this position, which position? Either in 5 or in 2, then the greater electrostatic interaction will be there, so that the stability will be increased. Okay. So the second stability for 3 and 4. Right. 3 and so the second stability is for 3 and 4. And the last one is 2 and 5. Okay. So among these resonance structure, which one is the most stable? Most stable is not consider the neutral one. Among the charged case, which one is the most stable resonance structure? 3 and 4, where the negative charge is in the neighboring position. So this is considered as the most stable resonance structure compared to this one. Okay, so the most stable resonance is that. Listen, I think you know the concept of resonance and canonical structure like that. These all are contributing structures. Listen, these all are contributing structures. Canonical structures which have a definite contribution to form the hybrid. These all are hypothetical structures. Okay, the real molecule is like this. The real molecule is a hybrid, okay? But this hypothetical structure have a definite contribution in this structure. Their own contribution in this structure. That's why we can't imagine the negative charge here, right? If only there is a hybrid structure. Once we know these all are the canonical structure, then only we can realize that here is a negative charge, negative charge, negative charge, negative charge. Okay, so in order to explain the whole property of a molecule, we choose more than one canonical structure, and that phenomenon is said to be resonance. I think you are familiar with that. In order to explain the whole property, we want to imagine more than one Lewis structure, and the structures are said to be resonance structure, canonical structure, or contributing structures. Okay, so to describe the whole property of your pyrrole, we want to explain this structure, but these all are not actually existing. These all are hypothetical. Okay, but a definite contribution from this structure will be there in your hybrid. The real molecule is hybrid. Okay, ready? And the most stable structure from this contributes more for hybrid. Among this canonical structure, the most stable structure may contribute more. Okay, so this hybrid have a greater character of most stable structure. Agreed? Okay, so this hybrid have a greater character of 3 and which means this hybrid have a greater electron density tendency of 3 and 4. Where is the 3 and 4 is most stable? Where the negative charge is in the 2 and 5 position. Okay, so it is clear that the most tendency of electron density or most chance for the electron density of this pyrrole will be 12. Okay. Because from the canonical structure, the most contribution is from most stable structure, where the most stable structure have electron density in the neighboring position. Okay. Actually, all positions have negative charge, where the most electron density will be here, because the pi role have a character of most stable structure, where the electron density is in 2 and 5 position. Okay. Right. That's explanation. Next question. Which of the following compounds shall not produced by propene HBr by elimination or direct only by elimination? So the following compounds shall not prepared by shall not produced propene by the reaction with HBr. It will be C, right? A can produce, right? A can produce. Why? Cyclopropyl ring is not a most stable ring. It may cleave, you know. It may cleave. This is not a most stable ring. So it may cleave with the HBr to form bromopentane, which followed by elimination to form propene. So there is a chance for formation of propene from the first molecule, right? Agreed. What about the second molecule? There also a chance, because the OH minus may be replaced by Br minus. Okay. Alcohol have a reaction with the hydrogen halide. I think you are familiar with the Lucas reagent. Lucas, that's where the reactant is concentrated HCl, not anhydrous HCl, anhydrous ZnCl2. Anhydrous ZnCl2 helps to cleave the bond. The reacting part is concentrated HCl. Okay, so alcohol can react with the hydrogen halide, where OH minus will be substituted by halogen. So if your OH minus is substituted by bromine, followed by elimination, you obtain propane, right? Is it okay? So B is where it is possible. D, it already eliminated to form the compound. So C is, there is no possibility. Okay, that is methylene carbonyl. What about the next? Next is already discussed in your note. Okay, the choice is C. Ready? The next, this is already discussed. The compound which will react most is readily with the gaseous bromine. That's propene A. I think this question is discussed. Propene is the smallest alkyne with allylic position. Gaseous bromine means bromine in high temperature. The exactly same question is given in your note, okay, in case of substitution reaction. Alkane, in the chemical property of alkane, halogenation, I think it is given to you. Check it. It is in your note, okay? Propene can easily react. Propene have an allylic position, so it can easily react with the gaseous bromine. So your choice is C3H6. The choice A. Next question. The correct statement regarding number the eclipse B is the answer. You know, staggered is more stable than eclipse. Okay. Staggered conformation of ethane is more stable than eclipse conformation, because staggered conformation has no torsion state, because that is in the maximum distance. Okay. Choice is B. Next. The question is also discussed. If KHSO4 is added, what happens? Slower, right? Nitration will be slower. Next, you know the hybridon in the given carbanion. Carbanion have the same hybridization that of parent. Okay. If your parent is a single bond, you have a single bonded carbanion. the hybridization of parent is sp3. So your carbanion also have sp3 hybridization. If you have double bond carbanion, the parent is double bond have an hybridization sp2, carbanion also have hybridization of sp2. If a triple bond carbanion, your parent triple bond have an hybridization of sp, then your carbanion also have hybridization of sp. So what is 2 p? sp, b, choice b. What about the next? First of all, sodium in liquid ammonia forms ethene, right? There is no stereo. That's actually a Birch reduction, agreed. Okay, but we don't want to consider the stereo arrangement. Okay, so what about the first? And you know the second reaction, sodomide and liquid ammonia. So sodomide can replace that's not actually a Birch reduction. Sodomide is not sodium in liquid ammonia. Sodomide in liquid ammonia, where there is no, that's already terminal position, right? Okay, so there is a replacement of hydrogen by sodium to form sodium alkynide, and your sodium alkynide with the nucleophile substitution with the, it is discussed in the preparation of alkyne. What will be the product? Okay. If your sodomide is in an inert solvent, then only non-terminal alkane become terminal. This if it is an inert non-polar solvent, then only the reaction takes place. This is a polar solvent, liquid ammonia. Okay. So the reaction is the liberation of Na plus, so that the substitution of hydrogen takes place. What will be the reaction? CH triple bond CH on treatment with the sodomide in liquid ammonia. In inert solvent only, it can change the position of triple bond to form a terminal alkane from a non-terminal. This is already non-terminal, no problem. So we can easily okay. So first the forms sodium alkynide. Sodium which undergoes a nucleophile substitution with the what will be your product? CH3, CH2, where bromine is substituted by C triple bond CH. Okay, so first you obtain but-1,9. The very same but-1,9, this is a terminal alkyne. So this is X. This can follow the very same reaction. Once again, what happens? Which one reaction with the sodomide in liquid ammonia? This hydrogen may be replaced by sodium. Okay, which again react with the alkylide. Alkylide is the very same. CH3, CH2, Br. Then the product will be CH3, CH2, C triple bond, CCH2, CH3, hex 3I. Okay. We know the idea. You simply replace. If we know this is a nucleophile substitution reaction, already told you that you simply replace the hydrogen by the alkyl. It is discussed yesterday. Here also replace hydrogen by alkyl. Okay. Ready. Next, in reaction with HCl, an alkene reacts with in accordance with the Marconi rule to give the product of 1-chloro, and the alkene will be. It is based on Marconi rule, you know. So what about the product in the first molecule? If HCl is added. If HCl is added, which one is the Marconi position? The position in a ring, right? Is it okay? What about the first molecule? That is methylene cyclo. Marconi position is this one. Because here we have 2 hydrogen, there is no hydrogen. Reaction with HCl, what do you obtain? Hydrogen goes to here and chlorine will be here. Ready? And you obtain 1-chloro, 1-methyl cyclohexane. What about the next molecule? That can also form the same, right? This is a Marconi position. Agreed? So if hydrogenated, here will be a chloro. Okay? So both are same, your choices, both A and B. Choice C. Okay, next. 2,3-dimethyl 1,2-butane. Hmm? 2,3-dimethyl. Oh. 1,2-butane means hello. I'm going to our class. ഇവിടെ നോക്കിക്കോ ഒറ്റ വെച്ചുള്ളൂ രണ്ടാളുടെ വിളിക്കൂല എന്തായാലും. എന്താ കാര്യം, ഞാനൊരു ക്ലാസ്സിലാണ്. വെറുതെ വിളിച്ചാ ആയിക്കോട്ടെ, ഞാൻ അവിടെ ഇല്ല. 2,3-dimethyl butane may be the question. Okay, 2,3-dimethyl butane. This is a molecule, right? Okay. 2,3-dimethyl butane can be prepared by heating which are the following compound with a strong acid. You know, they are given the alkenes. If alkene is on treatment with a strong acid, what happens? That forms a carbocation. Okay. So let me do the question with the first example. The first example, that is CH3, C, CH3, CH3, CH double bond, CH2. Two. 1,2-butane. 2-butene. ഇതാണോ 2,3-dimethyl butane? 1 2 3 4 5 6 1 2. This may be the question. Okay, 2,3 dimethyl 2-butene. Okay, so you are given with an acid. This is in presence of acid. Let this be the first molecule. This is in presence of an acid. What happens? Minus plus, that generates a carbocation. Okay, secondary carbocation. There is a methyl shift to form a tertiary carbocation. Hey, positive charge is here. Okay, followed by the last elimination. Elimination from alpha. What do you obtain? The most stable product will be size of product. Okay, so that's okay. Ready? We know that in presence of H plus there generates a carbocation. The carbocation rearranged to maximum. Okay, and it is clear that in your question you want to find an alkene. Okay, so finally you simply remove the H plus. First you added an H plus, then you remove the H plus. So there is a rearrangement through carbocation. So choice may be A. Next, a single compound of the structure. That's a reverse ozonolysis concept. Okay, you know that. Okay, reverse ozonolysis concept. So the structure is, there is a double bond, CHO, CH2, CH, CH3, CH2, CCH3, C double bond. Okay, so you know how to do this in a reverse pattern. 1, 2, 3, 4, 5. This become ring, right? Agreed. This become a ring. So ring of 5 carbon, where this is the first carbon and this is the 5th carbon. So this will be 2, 3, 4. And your first carbon have a methyl, third carbon have a methyl. Okay. So your choice is C. Reverse thinking. Next, there are some alkenes are given, right? You are asked to arrange them in heat of. So you simply consider the stability, reverse order of stability, right? So no doubt first one is more stable, so well conjugated. Okay, then the stability is for second one, then the stability is for third one. So third one is least stable, which means most hydrogenation. So 3 have greater heat of hydrogenation is inversely proportional to stability, right? So 3 have greater hydrogenation, so the stability lesser. Then 2, then 1. The choice will be D. Okay. What about the next question? There is a bromination of metaxylene, right? Bromination of metaxylene. Listen. Metaxylene in presence of bromine FeBr, where the electrophile is Br2 in FeBr3 means electrophile is Br plus. Okay, so Br plus may attack on the best position, and you know this is a plus R group, right? Okay, so since this is a plus R group, there will be the resonance effect of this CH3 in this ring. That means here will be a negative charge, here will be a negative charge, here will be a negative charge. Is it okay? Okay. So there is a resonance effect of this CH3. At the very same time, this is also a plus R group. Okay. So the same effect of this CH3 will be a negative charge, will be a negative charge, will be a negative charge. So these three positions are best. Okay. But this is a sterically hindered position. If the Br plus attacking here, there will be a repulsion. Okay, so it is better to attack the Br plus here or here. Ready? So choice will be C. Okay. Next, identify the sequential reaction. HBr in H2O2. HBr in anti-Marconico addition. Right? So what about the sequence? What about the reactant? That is but1ene. But1ene, which on? HBr, H2O2, anti-Marconico. The product will be CH3, CH2, CH2, CH2OH. Which one treatment is the sodium alkoxide? Sodium alkoxide means Williamson synthesis. I'm sorry. Fine. Br. Which one treatment is that? Sodium alkoxide. Sodium alkoxide is C2H5ONA. This is a nucleophile substitution, Williamson synthesis. Where the nucleophile is OC2. What is this one? OC2H5, which substituted here, so that CH3, CH2, 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 OC2H5. Okay, the choice will be A, right? What is A? CH3, CH2 thrice OC2H5. OC2, choice will be A. Okay. Next, which of the following organic compounds has same hybridization that of combustion product? Combustion product is carbon dioxide. Carbon dioxide, you know, sp linear. Carbon dioxide is sp linear. So always the hydrocarbon combustion product is carbon dioxide. So the hybridization is sp. So which of your hydrocarbon have the same hybridization? Alkyne. Alkyne mean should be ethyne. The next, Friedel-Crafts reaction will not undergo in nitrobenzene. Nitrobenzene, aniline, carboxylic acid, aldehyde, where FC reaction is not possible. Okay. What about the next? Non-aromatic. First one is benzene, aromatic. Second one is naphthalene, aromatic. Third one is that thiophene? One, two, yeah. 4 carbon. That's thiophene, fine. Thiophene is aromatic. Furan thiophene is aromatic. So D is not aromatic because the corner carbon is sp3. Okay. In molecule D, the corner projecting carbon is sp3. sp3 means non-aromatic. What about the next? Oxymercuration reaction. The product P not give. Product P is an aldehyde, right? Acetaldehyde. Acetaldehyde can give tolerance test, no problem. Acetaldehyde can form silver mirror with the tolerance reagent. Brady's test. Brady's test means a reaction with the Schiff's reagent. It will be reaction with the primary amine. Okay, reaction of aldehyde carbonyl with the primary amine is there with Bosch's reagent, Brady's reagent. Okay. Hi, I'm sorry. Brady's reagent thannalle. Ado 2,4-DNPO. Oh, sorry. 2,4-DNP is Brady's reagent. 2,4-DNP. 2,4-dinitrophenylhydrazine. Okay, aldehyde and ketone can react with the 2,4-DNP. Okay, fine, no problem. Brady's reagent will be discussed in your aldehyde. Okay, so acetaldehyde can show. Victor-Meyer test is the wrong. Victor-Meyer test is the test for identification of primary, secondary, tertiary alcohol. Primary, secondary, and tertiary alcohol. Okay, RBC test. Primary alcohol have a coloration of red, whereas secondary alcohol of blue, tertiary alcohol is colorless. Okay, and that's a test for alcohol. The aldehyde which only give iodoform test is acetaldehyde. So acetaldehyde is a product, so it can show iodoform test, no problem. Okay, so your choice, that is C. Next, major minor. Major is a rearranged 1A, right? That's not actually Markovnikov addition, that's a rearrangement mechanism. Acidic hydration, right, of alkene. So there is a rearrangement, methyl shift. Agreed? So the major product is A. Next, which of the following not exhibit optical isomerism? Malic acid is geometrical isomer, okay? Other can show. Alpha amino acids are optically active except glycine, you know. Lactic acid, tartaric acid all can show optical isomers. The next, which of the following reagent is able to distinguish butanine and butane? Sodomide. Because sodomide can form a salt with the terminal alkyne. Terminal, but not with the non-terminal alkyne. Okay. Next, the most stable conformation of N-butane, that will be anti-staggered. Right, anti-staggered means both CH3s are in opposite position. Choice B, right. You know the conformations of butane. Next, liquid hydrocarbon can be converted to gaseous hydrocarbon by cracking. Why? You know, hydrocarbon of, we already discussed the properties, right? Properties, C1 to C4 is? Yes. The higher hydrocarbon means it may be liquid. See, up to C17 it is liquid, and it can be converted to lower hydrocarbon by means of cracking. Okay, so liquid hydrocarbon means a hydrocarbon of heavy, highest member. Okay, into mixture of gaseous hydrocarbon means hydrocarbons of lowest member. So that can be possible through cracking. So your choice is B. The next, chlorine, sunlight, toluene, what happens? The reaction of chlorine in presence of FeCl3. There exactly the mechanism changed. Listen, you have toluene. Toluene, what is the specialty means? Toluene is a plus R group, right? So it can have an extra electron density in ortho-para position. Moreover, toluene is a benzylic compound. This is a benzylic compound. So it can show electrophilic substitution to the ring and free radical substitution in the side chain. This is a molecule with the toluene is a molecule with the benzylic group, right? So if the chlorination is in presence of FeCl3, the mechanism switched on to electrophilic substitution, so that toluene can form ortho or para substituted product. Okay, if the very chlorination which is in presence of sunlight, the mechanism switched to free radical substitution. Well, the free radical substitution possible in benzylic position. So this forms benzyl chloride, here forms orthochlorotoluene. Both mechanisms are discussed, right? In presence of FeCl3, what forms? Orthochlorobenzene, right? In presence of, so there is what? Orthochloro and parachlorotoluene. What about the Y? Benzyl chloride, right? Trichloro? That's also possible. Repeated chlorination possible. So you can choose the better choice as C, okay? Because there is a mixture of orthochloro and parachloro will be there, and there is a chance for excess chlorination, okay? So relative, this is a single choice question, so you have to choose relatively better one, okay? So the choice is, better one is C. Next. Okay, the first reaction will be discussed in your carboxylic acid. Carboxylic acid. That is any compound. This is only condition. Any compound having benzylic hydrogen. Benzylic hydrogen means you know the benzylic portion. This is the benzylic portion. Where the hydrogens are said to be benzylic hydrogen. Any compound having at least one benzylic hydrogen, which on treatment with the alkaline KMnO4 or a top oxidizing ion, whatever be the other valency, that completely knocked out to form benzoic acid. Okay, whatever be the valency, no problem. Listen, I'll give you an example. If this is a molecule which on treatment with the reagent, what do you obtain? You obtain phthalic acid. Why? Here is a benzylic hydrogen, here is a benzylic hydrogen. Whatever is the other valency, no problem. If there is a benzylic hydrogen, the rest is knocked out to form COH. Okay. So this reaction will be discussed in your carboxylic acid. This can be considered as a method of preparation of carboxylic acid. Okay. So for this reaction, we require this. Okay. Any compound having at least one benzylic hydrogen, at least one is required. Whatever be the next, no problem. It becomes COH. Okay. So there is said to be side chain oxidation. So side chain oxidation is actually here, right? Because either benzene have benzylic hydrogen. So the first B, the B will be, B is what? Benzoic acid. Benzoic acid, the molecule is a minus R. COH is a minus R group, right? Yes or no? Yes. So which on bromination, what happens? Meta bromo benzoic acid may form. Okay. Fine. Listen, which followed by substitution, right? Which followed by substitution of C2H5OH. Actually, there are two chances. That means you may think that this can substitute bromine, but in haloiodine the nucleophilic substitution is restricted, right? Okay, there is no nucleophilic substitution because if halogen is to the ring less, you know the reasons. So there may be a chance for esterification. This is a reaction of acid with the alcohol in presence of dilute sulfuric acid or acid. So there is a chance for esterification. Esterification means OH from here, leave H from here and connect them. So this will be the product, okay? And it will be okay if you know esterification, and esterification is discussed in alcohols. Okay, that means in case of a sequence you have to know every chapter. To solve a sequence level problems, you have to know every reaction. Okay. Now. Okay. Next 73. Which of the following conformer of ethylene glycol is most stable? That's D. Okay. Some molecules where the Gauss staggered is stable due to hydrogen bonding. Okay. If here is OH and fluorine, OH and OH, OH and chlorine, like that, there is a chance for OH and NH2, NH2 and NH2. There is a chance for hydrogen bonding. Due to that hydrogen bonding, this Gauss conformer is stable. Okay, normally the conformer which is most stable means anti-staggered. But in case of in some cases, there is a chance for the stability for Gauss conformer. So your choice is D actually, okay? What about the next? Hybridization of C2, C3, C4. C2 SP, right? C5 SP2. C3 SP3. So the order is C2 SP, SP3, SP2, SP3. Choice D. Which of the following will exist resistance isomer? 2-butene. Yes or no? Yes. Then benzene with the CH3 CLM plus of anhydrous Cl3 forms toluene. So that's Friedel-Crafts alkylation, right? Friedel-Crafts alkylation. Friedel-Crafts alkylation. So the choice is D, toluene. Next. What is next? The reaction of question number 77 is the options ille. No problem. You know the major product. You know the major product. Is there any shift? Is there any rearrangement? Yes. Then what will be the structure of major product? CH3 CHBr, CH3 CHBr, CH CH3 CH3. Is there? Oh, wait. There is hydrate shift actually, right? No, I'm sorry. CH3 CBr, CH3, CH2 CH3. Okay. CH3, you know what to do. Enough. You know what to do. That's enough. Move to the next. What about the next? 1, 3, 5. 1 is SP, 3 is SP2, 5 is... Actually there is no, 2 choices are missing. Okay. Now I think you know the product. Fine, that's enough. 1 is SP, 3 is SP3, 5 is SP2. Yeah? D. The hybridization of 1, 3, 5 are asked. Okay. So SP, SP3, SP2. D choice. The next is predict the product in the reaction of. You know that is a geminal Markovnikov addition, right? First of all, in presence of HCl, what happens? Cl on the second position, hydrogen on the terminal position, followed by Hi. So iodine on the second position, right? Your product will be C. The next. Which are the following compound with the molecular formula C5H10 yields acetone or non-soluble? Acetone. First one is 2-methyl-butanone. This is 2-methyl. What about 3-methyl? 3-methyl. This can produce acetone, right? 2-methyl-butene. Yeah, there is a chance for acetone. Okay, there is the chance for acetone. So your choice is D. Yes or no? Yes. Question number? Up to 80 is okay. 80 is over. Question number 20. 22. Good. Answer it. Answer. Other 80. Question number 22. 22 is an elimination. Okay. You know, beta elimination. Methoxide, alkoxide ion is there? Because the acidity of water is more than alcohol. Acidity of water is more than, so that's why alkoxide ion is a strong base. So here there is a chance for elimination. Okay. Choice B. 23. Our expectation is, what is it saying? 3-phenyl propene. 1, 2, 3. 3-phenyl propene. Here is the bond, right? Our expectation is this one with the HBr, right? Normal. Our expectation is through rearrangement it may be like this. Okay, this is an actual product. But in this question there is no product like that. Okay, so we can simply consider the Markovnikov product. Okay. Right. So I told you that this is a multiple single choice question. So you should choose relatively better one. So if this one is in the choice, you can choose this. No problem. In the absence of this will be the major product. Okay. So it is over.
Acetone reverse mechanism will remove the oxygen.
Either any one of the product is acetone. No need to form acetone only. Okay. Right. So the choice is 4. If there any question like this, you can horizontalize these products, means this reactant, then it will be more easy. Okay. If there yield acetone, if the question is acetone only, then okay, this is okay. Otherwise it will be
So here you got dye substitution. Like this, you put the arrow and you told dye substitution as well. Then here also 1, 2, 3. 3 will come also. That's what they asked.
okay. Total substitution, right? Listen, question number check the question number 34. Question number 34. Pen 1 in, pen 2 in, this one. Okay, these are the possibilities. Tri-substituted alkene, right? So you have to consider the total substitution. Total substitution. So the total substitution means total number of alpha carbon. Alpha, 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 alpha. So chance for tri-substitution is also there. Okay, tri-substituted alkene is alkene. Not only with respect to a single unsaturation, tri-substituted alkene. So first of all, you have to design the all possibilities in pentene. Then only you can think. So monosubstitution is okay. Disubstitution is okay. Tri is also possible. Okay, so choices all will be the answer. Okay. So hydrocarbon is over.